Happy Monday! I hope everyone's having a great morning so far, and you're just ready to kick off your Monday with a good Network Plus video. This lesson is going to be over network topologies. Yay! So all a topology is where things are connected, how they are connected. So the definition from Google says topology is the way in which constituent parts are interrelated or arranged. And let's take this arrangement, for instance. We can say that this is a topology, and all that means is how these clients are arranged in accordance to the switch or the hub. And that's all it is. So I hope you're ready to dive right in. So our first one is a star topology, and I've written a few notes, so I'll go ahead and read to you what I have down in my notes, and then we'll go over it a little bit more. Star topology, all components connected to centralized device, that is this icon right here. This is going to be our switch. But once again, all components connected to centralized device, physically interconnected determines the physical topology. Star topology, most popular physical local area network topology. Whenever you're looking at a local area network, you're most likely going to find a star topology. This is what is the most popular within that geography. The technologies of our star topology are Ethernet switch at the center of the star, unshielded twisted pair or UTP, cable connects from switch ports to client. So this is our Ethernet switch, and then the cable that's connecting our technology when we're looking at the cable or the cable technology is going to be the UDP, unshielded twisted pair. Let's go ahead and look at this the yellow part. I put the yellow part here to represent the star, to just make it, whenever you look at it, you're like, oh, okay, that's the star topology, instead of just having, our cable, our client, as well as our switch here. You can actually see a star, so I don't know, I was trying to make it a little bit more friendly. But so moving on from just the symbol of the star, we're going to look at the red lines, and this is our technology, the unshielded twisted pair cable, and this cable is all connected to a switch. This is our centralized device, and our centralized device then connected through the unshielded twisted pair to a client. So then a client can access the switch, and the switch can talk to the client. A few more notes that I wrote down were, this is an independent connection. It's commonly used with internet technologies. Cable break only impacts device connected via broken cable. So all that means is if this cable were to break, this switch's ability to communicate with this client is not affected. And that is because these two have a relationship with they have a cable between them. So the breakage of this cable does not affect the communication, the traffic between these two devices. It is simple. More cable is required, and that is just because for every client it's connected via cable. It's not just one cable is linked to every client. Installation can take longer. Ooh, looks like we have a ring. And once again, I have added the back portion of, a representation of a ring, just a circle. And that's just to make it a little bit more user-friendly, instead of just giving you the client and then the connection. Ring topology allows devices on the ring to take turns transmitting on the ring. Contention is not a problem. Fiber distributed data interface, FDDI, has fiber optic media. Use not just one media, but two sent data in opposite directions, resulting in counter-rotating rings. Benefit is if a fiber broke, these stations or clients, I would say, on each side of the break can interconnect their two rings, result in a single ring. So what's happening here with our ring is going to be much slower than our star, because our star has a direct connection to the device that it needs to send traffic to, unlike the ring. The ring has to, okay, let's say that this little device needed to talk to this device. It would need to send directly to that device, which, isn't a problem when it's its neighbor, its immediate neighbor right there. But let's say that this device needed to communicate with this device. This device can't just go this way. It's got to go all the way through these devices, and the devices got to look at the traffic and say, oh, that's not for me. Oh, that's not for me. Oh, yes, that is for me. And then this client can say, blah, 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 whatever it needs to do, or just read the information that the device was sending to it. And then it can send, and that's how the ring works. It's gotta go through each device to get to the right device. Unless you have like a dual ring, then the traffic can go both ways. My last notes for this ring would be interconnected by connecting single ring, receiver, transmitter. So I was saying that it is a receiver and it's also a transmitter. Each device on the ring repeats the signal it receives. Dual ring topology is fault tolerant. Troubleshooting is simplified and it reports errors. So if there was an error to occur during the traffic flowing, then it would say, hey, there's something not right here. So it's smart. Scalability limitations and cable required for a ring is usually higher. Let's go ahead and move on. Yay, we have a bus. The buses are a little bit troublesome. So let's go ahead and read what my notes say. Devices used to connect to the network then tap into nearby cable. Let's say that this is a client and this is also a client and they needed to talk. So this client needed to say something, but also this client needed to say something, and they didn't want to take turns or didn't realize that the other client was saying something. So let's say that they sent traffic in at the same time. There's going to be a collision. Technologies are T-connector, older 10 base 2, and vampire tap, older 10 base 5. Bus and all devices connected to the bus is on a network segment. Single collision domain, one cable, requires transmitter, less cable, less expensive. Potential single point of failure. Troubleshooting is difficult because problem isolation. Installation is easier than some other technologies. Adding devices to the bus might cause an outage or other users on the bus. It doesn't scale well. What is going on is, once again, if someone needed to say something here, but they also did, and they sent at the same time, then there's going to be a collision, and then there's going to be a brief moment or a set time where both clients realize that there was a collision, so they wait for each other. And once they think that it's fine, then they'll send more traffic, but again, a collision can occur. And it won't be so bad the least clients you had. Like, let's say you had just 2 clients and collision shouldn't happen too awfully, but say you had 2,000, then the collision is going to be absolutely awful because nobody is going to get information out in a very efficient or effective way. Okay, we have a hub and spoke right here. And let's see, a hub and spoke minimizes wide area network expenses by not directly connecting any 2 spoke locations. The communication is sent via hub locations, connect back to main site, communicate between 2 remote sites, travels through the hub site. Costs are reduced. Adding 1 or more additional sites is easy. Potentially becomes a single point of failure. Anytime you hear single point of failure, that's like the worst thing ever. Because, like, let's say that something happened where there was a collision and, we have a break time from when the collision happened to when repairs need to be made. And during that break, information isn't going to be able to be sent anywhere because you have a single point of failure, which means that there is no door to that you can go to send out information. And we have a full mesh here. Because each site connects directly to every other site, an optimal path can be selected, as opposed to relaying traffic via another site. This is highly fault tolerant. Every site has a direct wide area network. Optimal route exists. Troubleshooting is easy, difficult, and expensive. And it's expensive because you're using so much cable. Like you don't just have a single cable, like with a star where it's like dirt dirt, you got point to point. It's like if we look right here, this guy's got four cables connected to him. He's got one where he can talk to this guy, he's got one he can talk to this guy, everyone. But though it's expensive, it's also going to be the most effective. I hope that is the right. To me, it's going to be the most effective because no matter if this cable broke, you're still going to be able to communicate because you can send info to this guy and then you can send info on. And then lastly, we have partial mesh, which is a hybrid of hub and spoke and full mesh topology. Partial mesh can be designed to offer an optimal route between selected sites while avoiding the expenses of interconnecting every site to every other site. Selected sites via direct links. Partial mesh uses fewer links and more links than a hub and spoke. Provide optimal routes, more redundant, less fault tolerant, more expensive. Lastly, we're going to go over 3 wireless topologies. For the ad hoc, the book says that this is the simplest. Yay! We have the simplest wireless network. Ad hoc. Wireless nodes are in charge of sending and receiving traffic to each other without the assistance of infrastructure devices such as switches or access point. Engineers refer to the ad hoc topology as simply a wireless peer-to-peer type of network. Awesome. So if we move on, we have infrastructure. This is specialized wireless equipment for permitting the wireless communications. Wireless access point WAP allows the various computers and other wireless devices to communicate with each other through the WAP wireless access point, acting like a hub device. And lastly, we have mesh wireless topology. Mesh is a specific type of ad hoc wireless topology, and this topology is more sophisticated than the ad hoc in that specialized nodes help move the traffic throughout the topology. I hope you guys have a great Monday. I hope you learned something from this video.